All programmers test their code to verify it behaves the way we expect. Unit tests are the most common type of developer test, and most of us rely on a unit test framework to create and run those tests. Hey there, I'm Walt Ritscher. I'm a longtime Visual Studio user, and I want to show you the unit test tools available in the Visual Studio IDE. We'll look at two frameworks, xUnit and MSTest. You'll see how to create unit tests with each framework, compare their features, and show how each one is fully integrated into the Visual Studio Test Explorer. I'll look at some popular features like CodeLens, live unit testing, and code coverage. Also on the agenda is a look on how to debug unit tests and how to make data-driven parameterized tests. It's time to start testing your code. Let's go. During this course, we'll explore the unit testing tools available in Visual Studio. This is not the course for explaining how to unit test your code. We've got plenty of other courses in our library that cover those topics. I assume that you want to unit test and understand the basics and want to see how to create and run unit tests in Visual Studio. On a related note, we won't be talking much about test-driven development (TDD) or behavior-driven development (BDD) concepts. I will say that I favor the BDD approach and have structured my examples to follow some of those patterns. If you are not familiar with BDD, don't worry. The code we are testing is simple, so we can focus on the test tools, not the pattern. Unit testing is available for all the editions of Visual Studio. I'm using Visual Studio 2019, but you can run unit tests in older versions too. Also, the unit test features differ based on which edition you have. I'm using Visual Studio 2000 Enterprise Edition, which has additional features which you see in this list. I will demonstrate live unit testing and code coverage in the course. Be aware that you must have the Enterprise Edition to use them on your own computer. Let's take a minute to talk about what you should know before taking this course. Familiarity with the .NET Framework or .NET Core is valuable as we will be testing .NET code. The source code for this course is written in C#. To be clear, the unit testing tools work for all the Microsoft languages, C++, Visual Basic, and F#. Since the examples are in C#, familiarity with C# is valuable. Now that we've established the general idea of the course, it's time to explore the unit testing tools available in Visual Studio. If you are interested, I've got another Visual Studio unit test course available. There is some overlap in the content. I thought I'd explain what is the difference between the two courses. In the other course, I show how to create a unit test framework. In the real world, most developers use a third-party testing framework. We don't build our own. But I thought it was important to show how the internals of a unit test framework are constructed. It helps understand what is happening. If you are interested in studying how to build a test runner or use .NET Reflection to discover test methods, I suggest you watch that course. In this course, we'll write most of the tests with the popular xUnit testing framework. Choice of framework is ultimately up to you and your team. For me, I choose xUnit whenever feasible, so that's what we're focusing on in this course. If you haven't worked with it yet, this will give you an opportunity to see why it has a devoted audience. The other two popular frameworks are MSTest and NUnit. I'll show some MSTest in this course, but I'm skipping the NUnit framework. To be clear, Visual Studio has full support for NUnit. If you are interested in learning more, check out my older course. There are additional reasons to watch this course. For one, we'll look at the improvements in the unit test tools in Visual Studio. So really, you can enjoy both courses. Watch this one to see details about xUnit and the newest Visual Studio features. Explore the other course to see how to use .NET Reflection to write an example test framework or see how to utilize NUnit. I like to customize my programming environment. I'm not alone in this desire. I'll wager you have tweaked your command shell or customized your Visual Studio color theme too. I want to show you some of the configurations and tools I use so you know why my environment looks and acts the way it does. To be clear, you don't need to change your setup to follow along in this course. Keep your tools and configurations the way you like. However, if you see something you like, now you know what it is and where to find it. I don't use the shell much in this course. The only time I use it is when I'm cloning the GitHub repo at the beginning of the course. My choice is the new Windows terminal with PowerShell. It has a personalized background. I'm showing an image, the PowerShell PNG file. Plus, it has a customized prompt that incorporates a custom path, Git repo status, and more. Note the blue text is the path information. See how it truncates the path as it gets longer? The yellow text is for Git information. It shows the current Git branch. I can see I'm working on branch 07-02. If you'd like to modify your Windows terminal, you can find articles on how to customize it on the internet. Search for Windows Terminal and also search for Posh Git and Oh My Posh. There are many good programming monospace fonts available. I like several. Currently, I'm using the Microsoft Cascadia code font. It's the default for Windows Terminal, so that keeps my environment consistent. One nice benefit of these modern typefaces is their support for ligatures. Ligatures are special visual symbols for multi-character operators that make code easier and faster to read. I've got a few Visual Studio extensions installed. The one that I want to highlight is the VS4a extension. It applies a custom colorization to the code editor. For me, I really like how it changes the colors of nested braces. I think it helps you understand the code better when reading it in the course videos. The colors are configurable, and you can choose how extensive the changes are. For example, do you want it to change the colors of the branching keywords like if and then? Here's a screenshot that shows Cascadia font ligatures and VS4a in action. On lines 13, 14, and 15 are some ligature examples. This is a subset of the possibilities. Now look at line 18 for a more concrete example. There we can see the lambda arrow and the not equal sign in the expression. In my opinion, these look tidier and still convey the code intention. Next, check out the VS4a curly brace colors on lines 26 through 30. Each nested level uses a different color. This helps finding the matching top brace. Look at line 28, then at line 12. That green color helps me affirm that I'm looking at the correct match. Yes, Visual Studio draws lines between the braces too, but I still think the colors help. Also, it works for parentheses. Look at line 18 again. See how the inner set is orange and the outer set is purple? Or for an extreme case, look at line 23. That's a lot of nested code. Another feature of VS4a appears when pressing Control Spacebar. It colorizes the area between a set of braces based on the current cursor position. In this example, it makes it easy to see what's contained within the purple curly braces. This also works for square brackets and parentheses. Now you have some idea of what I use and how it affects the Visual Studio IDE. Remember, I said earlier, you don't need to change your setup to follow along in this course. Keep your tools and configurations the way you like, or borrow some of these ideas if you prefer. All the code for this course is freely available on GitHub. You can find it in our LinkedIn Learning Organization account in this URL. You will need to clone the repository to your computer if you want to follow along. This is how I usually do it. I would go to the green button and choose to copy this URL. Now, before we go over to Windows Terminal and clone the repository, let's talk about branches. There is not much code in the main branch. It's all in the other branches. For example, look at this first branch, 01-03. In this branch, you'd go to the source folder, then to this SLN file. This is what you would open in Visual Studio. So we need to clone the repository and then switch branches. To do that, I'll switch to Windows Terminal. Here you can see it on the right side of the screen, and on the left side of the screen is Windows Explorer. So we can see the creation of the folder. I'm in my repos folder. I'll paste in the URL, clone the repository. Then I'm looking to move to this Visual Studio folder. And now that I'm in the folder, you can see that this lights up on my prompt. It tells me we're on the main branch. I need to switch to a different branch. I'll maximize this so we can see more. I'll check out that branch. You see my prompt updates to show I'm on the new branch. Try that again. I made a typo. And now I can see there's that SLN file. So that's what I want to open in Visual Studio. We'll go to the File menu, choose Open, Project or Solution, drill down into this folder, double-click on the SLN file. And now you're ready to start following along on the course code. You may have experience with Git and GitHub, but be aware that using Git with our exercise files can be a different experience from using Git on traditional programming projects. We have a course on the differences called Working with LinkedIn Learning Exercise Files on GitHub. I created the course with my fellow staff instructors Ray Villalobos and David Gasner. Check it out for details on the common Git operations you need and how we use branches in course examples. I'm glad you joined me for this course. This video summarizes what is on the course agenda. I'll spend a lot of time looking at the Visual Studio Test Explorer, which is the test runner included in Visual Studio. We'll see how to run tests and examine the results. We'll see how to debug test code from the Explorer and how to group and run subsets of the tests. One key feature in Visual Studio is the ability to use any of the popular unit test frameworks. This course uses xUnit for most of the tests, but I'll show you how to use MSTest and explain the differences between the frameworks. We'll also explore these topics. The code coverage feature helps determine what proportion of your project's code is being tested by your tests. CodeLens is the miniature data bar that appears in the code window above every method. We'll examine what unit test information is available in the CodeLens and see how to run or debug tests from it. Another nice feature is live unit testing. It automatically runs any unit tests in the background as you modify the code. Then it presents the results in real time. Equally important is what I'm not covering in this course. I'm looking at the tools in Visual Studio that enable unit testing. I'm not talking about coding philosophies like test-driven development or TDD, where the tests are written first and the code is built after the tests are in place. Don't get me wrong, TDD is a highly regarded discipline with many advocates. It's just not the focus of this course. In the same spirit, I won't look at behavior-driven development either. BDD is another programming philosophy that relies on unit tests. I do like how BDD defines names, however, so I will borrow some of their naming conventions for my test names. Another topic that is important for writing isolated, decoupled tests is the concept of test doubles. They are important when you have dependencies on external components, but you can't rely on using the real components during the test. Concepts like mocks and stubs and shims are essential to building robust tests in complex systems. I won't cover the topics in this course, but search for mock on our website to learn more. Another relevant topic that is not in this course is how to run tests from the command line or in your continuous integration pipeline. It's true that many shops are turning to automated or scripted testing. It just makes sense to trigger a test run whenever code is checked into source control. Yes, automated tests are useful, but they're not on the menu for this course. Check out my Azure DevOps course if that sounds appealing to you. That's a quick look at our agenda. Next up, what are unit tests? Programmers write code. That's what we do. An essential part of the process of writing code is testing that it behaves the way it should. The most common test we do to verify behavior is called a unit test. A unit test is a piece of code written by a developer. This code has nothing to do with our problem domain. It exists to test other code, the code that is in our applications and APIs. Since unit tests are code-based, you have to choose a programming language for the test. Most of the time, the tests are written in the same language as the code under test, but that is not a necessary stipulation. You could test a C++ API with C# unit tests. We are testing the behavior of our code. Does it do what is intended? In practice, this usually means each test is small in scope. It exercises a very small, specific area of functionality of the code being tested. Usually, a unit test focuses on some specific method or function and how it behaves in a particular context. Depending on the behavior of the method, it might be necessary to create multiple tests to verify the code works correctly in different scenarios or with different input data. For example, does it work with missing or incomplete data? How does it handle edge cases? This is not a place for the philosophy of how to test your code, but a general rule discovered from the behavior-driven development world is this: tests are best when testing the public API of your classes. By API, I'm not talking about REST APIs and the like. Here I mean the public methods of your types. If we follow this philosophy, it means we shouldn't test private methods. This is the approach I'm following in the course. There are arguments for and against this methodology. One reason I prefer this tactic is that it avoids coupling between the application API and the unit tests themselves. Whether you agree with this approach or not, the important lesson is that unit tests are best when we create lots of small, focused tests to verify that the behavior of our code is what we want. Every developer does some type of unit tests. How we do them depends on experience, team dynamics, and what testing tools we use. Impromptu testing is where we all start when we are novices. We write some code, then figure out a quick way to test that it works, then move on and write more code. Often, this is as simple as running the code, providing some input data, and seeing if it works. We have no formal plan, and nothing remains of the impromptu test after we're done, which makes it difficult to repeat. This is how many of us learn programming, but it is a dreadful approach for professional level development. Some teams and companies have their own automated testing tools, created as needed by the team members and still used in development. I know I've seen a few of these homegrown solutions in my consulting days. More common, at least nowadays, is to use third-party unit testing frameworks. Let the experts build a robust system, we'll use it and get on with our coding. Some of these are created by the companies that create the programming IDEs. That's the case with MSTest. Useful IDEs are usually flexible, allowing third-party frameworks to leverage the IDE tools. That's how Visual Studio works. In summary, unit tests are code-based tests that are written by programmers explicitly for testing the behavior of their code. In TDD, you'd write the tests first, then create the application code that passes the test. This assumes that you know the expected behavior before creating the test. In BDD, you model the behavior, then write the code that implements that behavior, then write the tests to verify. Whatever philosophy you follow, it's important to see how to create and run the tests in Visual Studio. In this video, we'll start by looking at the system under test. There are two projects in this work with unit test solution. We have Brokerage Lib and Sales App. Brokerage Lib is the system under test. It is a .NET class library, and it contains the code that we'll be testing in the rest of this course. This represents code for our financial brokerage house. Currently, it has these 5 classes: account, commission calculator, commission constants, financial, and payment date. We'll look at the code in these files soon. In this video, we'll see a demonstration that shows some of the functionality of the code. We'll get an opportunity to see its behavior. I've created this WPF Sales app to help us see how it works. First step is to make this the start project, then run the application. This first tab is for the payment due date calculator. So the way this works is that we bill our customers, and when we create the bill, we set the calculated due date 30 days in the future. So for example, if I pick the 5th of June, you see on the other calendar that it selects as the payment date the 5th of July. It's the same for the 7th and the 9th of June. We have a business rule that states if the proposed due date is on a Saturday or a Sunday, it gets moved to the next Monday. So when I click on 10, you'll see that the calculated due date moves to the 12th. It's the same for the 11th and the 12th. And when I click on 13, then it moves to the 13th. So 10th, 11th, and 12th all have a due date of the 12th. Next, we'll look at sales. This calculates our commission rate for our sales reps. We have a multi-tiered commission rate. So the default or standard rate is shown here. Let's say that this sales rep chooses to sell 50 units at $10. So the total sale is $500. They get the standard commission rate of 8%, and they earn $40. We have a couple of other business rules that state if they sell over a certain threshold of units, the next threshold is 400 units. So if they go from 350 to 400 units, they get a raise in their commission rate. Now it's 11%. And there's another tier at 600. So here I'm at 550, go to 600, and the commission rate moves up to 14%. There's another rule that states if the total sale, doesn't matter how many units are sold, but the total sale is over some thresholds, then they get the increased bonus. So let's look at 100 unit price and 100 units sold. That means the total sale is $10,000. They get the standard commission rate. There's a bump when they reach $12,000 and another bump when they reach $15,000. If they sell $14,000, they get the middle tier. If they sell $15,000 or more, they get the highest rate. We also have some examples in loans. And as we go through the course, we'll spend most of our time writing unit tests for this calculate future payment date and for the commission calculator. As a developer, I always try to write readable, bug-free code. Most of the time, I have a good idea what the code should do based on the user stories or the application requirements. And at some point, I need to test the code to see if it meets my expectations. Does it do what it's supposed to do? We're looking at unit tests in this course, and we'll be testing this brokerage lib. This is a class library that is targeting .NET Framework 4.7.2. So our test projects will be referencing this project. I also have a reference to this project in the sales application that we saw in the last video. First place we'll look for code is here in commission constants. I have a top-level class called constants on line 3, and then I have 3 inner classes or nested classes on line 5, 11, and 18. I don't need to write any unit tests to verify the code in these classes because there is no logic in the classes. It's just constant values. Sure, I do need to verify that the business cases are being met by these constant values, but that's not the job of my unit tests. These constants are used in another class, this commission calculator. So let's take a look at that. So here I have a single method called getCommission for the sale. And I do need to write unit tests for this code because there's behavior in this method. I see some logic in here. There's some if statements. There's some if else's in here. So that implies that I do need to test the code in here. It's also the public method on a public class. So that's part of my public API. What do I have in here? Well, I have some guard clauses in here checking for negative values for units sold and unit price. And if that's true, then I throw some exceptions. So my unit test should check that the correct exceptions are being thrown. I'm also doing some mathematical calculations here. It's simple, but it's math. Units sold times unit price. So I'm checking on line 33 that the gross sale is greater than or equal to the epic sales amount, or the units sold are greater than or equal to the epic unit amount. If so, then our sales rep gets the epic commission rate. Then I do the same thing for the next tier, the earner tier. And if it's neither of those, then our sales rep gets the standard commission. I won't show you the code in the account class. Financial class, here we have some methods like get rate of return, get annualized rate of return, and one called calculate loan payment. So we would need to test these. And then finally, here's the code that calculates our future payment date. Single method in here called calculate future payment date that takes a starting date. It has a switch statement in there. So again, there's logic inside this method, which implies that it needs to be tested. And again, it's a public method in a public class. So that gives you some idea of what code we'll be looking at in this course. In this video, I'll look at the anatomy of a unit test framework, a broad look at the basics. Later in the course is a deeper look at how Visual Studio works with unit test frameworks. The way I see it, these are the major parts of a unit test system. First of all is our application code, often called the system under test. Then we write test code, which verifies the behavior of application code. Here's an example. This is my brokerage code library. I need to test some of the class methods in this library. In tester lingo, the brokerage lib is known as the system under test, and you'll occasionally see the acronym SUT used. When it's time to write the test, you have to decide where to put the test. In .NET, you can put the test code in the brokerage lib. There is no rules that prevent you from locating the tests there. The downside to this approach is that the test code is deployed with the library, not an ideal choice for production-ready code. Instead, it's more common to create a separate code library that contains all the test code. This test library needs a reference to the brokerage lib so that the test code can instantiate the classes and call the methods. There are additional parts. We use a test framework because it contains tools that aid in writing tests. The most common helper is the assert class, which we use to assert whether a value or object matches our expectations. Most test frameworks have a matching test runner, the application or plugin that runs the tests. There might also be a results viewer, which shows the information and results of a test run. Typically, you see these in GUI test tools and programming IDEs. Back to our example. The test lib has a reference to a unit test framework. In the .NET world, this might be xUnit or NUnit or MSTest. This test framework provides a selection of types and methods that simplify writing test code. Each unit testing framework has a dedicated test runner, the app that is responsible for running the test and returning the results. To review, we are responsible for creating the application code in the brokerage lib and the test code in test lib. Someone else creates the unit test framework and the test runner. We're leveraging them to automate our tests. About that test runner, it can be invoked in several ways. There is usually an executable that can be run from the command line. It would need some parameters, like the name of the DLL that contains the test code. And there might be optional parameters, like a filter list, to make it possible to run a subset of the tests. Most test runners are also callable from your continuous integration pipeline. Plus, many of them are callable from a developer IDE like Visual Studio. In this case, there are two test runners. The one in Visual Studio is invoked when you run the test. It invokes the real test runner, which does the work and passes the results back to Visual Studio. Unit testing systems are generally split into two phases, test discovery and test execution. The discovery phase is where the test runner determines which methods to call. Once it has the list, it calls them during the execution phase. Let's talk more about how multiple test runners work in an IDE like Visual Studio. The standalone test runner can do all the work on its own. However, in the IDE, they may share responsibilities, depending on your option settings. For example, Visual Studio might handle the discovery phase, building a list of potential tests and showing them in the Test Explorer. Or it may delegate that task to the test runner, asking it to get the list and then showing it in the Test Explorer. Most of the time, you don't need to worry about this. This collaboration is between the IDE and the unit test framework developer. How does the test runner know what methods to call in the test lib? Most test frameworks have a way to mark the methods that contain tests. In .NET, this is done with a custom attribute. The test runner examines all the classes in the test project and finds the designated test methods. Once it has the list, it runs the methods, gathers the results, and outputs the results so that we can verify the test passed or drill deeper to see what tests failed. Experienced programmers know that name choice is important when writing classes and methods. The same is true for test methods. Future you will appreciate test names that follow a logical and coherent naming convention. In this video, I'll look at popular naming patterns that strive to make test names self-documenting. In the definitive book, The Art of Unit Testing by Roy Osherove, he makes this statement about unit tests. Unit tests are just as much about documentation as they are about testing functionality. Assume that someone else is going to read your tests in a year. They should not have a hard time understanding your intent. A well-chosen name is part of that documentation. His suggestion for test names is to divide it into three parts, separated with underscores. See line 11? It starts with the method name you are testing. In the second part is what is called the state under test. Microsoft calls this the scenario. The third part of the name is the expected behavior. This is what should happen in the successful run of the test. Here's an example. Lines 16 through 18 are testing a method named calculate future payment date. Lines 20 and 21 are testing a method named get commission for the sale. In the center is the scenario. On line 17, it's when the proposed payment date is on Saturday. On line 20, the scenario is when there's a negative sales amount. This is the expected behavior. On line 17, it's when the proposed payment date is on Sunday. The date should be moved to Monday. On line 20, when there is a negative sales amount, the method should throw an argument out of range exception. Yes, the test names are long. The expected benefit is that each test name contains the information about the test, which is useful for documenting the test and when viewing in the Visual Studio Test Explorer. You might have noticed another drawback. When there are multiple tests for the same method, the method name is repeated on each test. Here's a technique that helps mitigate the issue. Use a nested class, also known as an inner class. Name the nested class with the method name under test. You can see an example on line 12. I've declared another class, an inner class called CalculateFuturePaymentDate. It makes the test methods shorter and more readable, and yet the context is not lost. Here's another benefit. The Visual Studio Test Explorer continues to show the relevant information. In this example, the top 4 lines show the original names. The bottom 4 lines show the new syntax. Notice that the Test Explorer shows the 2 class names, the test class and the calculated future payment date on the same line with a plus symbol between the class names. Then below that are the 3 test names. Another popular approach to naming test methods comes from the behavior-driven development, or BDD world. The concept of BDD was introduced by Dan North as an improvement on test-driven development and as a means of clearing confusion between testers, developers, and stakeholders. He had some thoughts on unit test names, including these 3 nuggets. First, an expressive test name is helpful when a test fails. This echoes the sentiments conveyed earlier in this video. Second, use a sentence structure where possible. This helps express the intent of the test. Finally, start method names with should. This concept accentuates that the class we're testing should do something. It should have a single responsibility. So the class should do something, and the method we're testing should behave in the way we planned. One thing that Dan highlighted in his thesis is that test names are better with the word should in the name. There are many variations on this theme. I'll show you the ones I like and use. Here's an example. Line 2 declares a class with the method name. This is the method we are testing. Each method in the class starts with the word should. On line 4, it should have this result underscore when condition. And on line 5, it is should have another result underscore when another condition. Once again, we see the repetition of a word at the beginning of a method, which follows the advice of BDD guidance. I have a revision I use. You see it on line 8. Put the word should at the end of the class name. That removes the redundancy from each method name in the class, yet it still reads like a sentence. This is the convention I'll use in the course. Finally, there are some BDD advocates that like to place the word should at the end of the method name. Personally, I'm not a fan of this approach, but I included it in case it appeals to you. Here's an example using real test names from the course examples. Let's read that first example, starting on line 2. Calculate future payment date should return date 30 days in the future when proposed date falls on weekday. Or what about line 9? Get commission for the sale should return standard commission when sale amounts are below thresholds. For me, this is a readable, understandable test name. The best advice is to pick a convention and stick with it in all your tests. If you choose one of the conventions shown in this video, you'll be in good company. Or you can build your own ideal naming pattern. Just be persistent, always write the test, and be consistent. Stay with your chosen naming pattern. I've said it a few times in other videos. There are 3 popular unit testing frameworks: xUnit, NUnit, and MSTest. Choice of framework is ultimately up to you and your team. For me, I choose xUnit whenever feasible. So that's what we're focusing on in this course. If you haven't worked with it yet, this will give you an opportunity to see why it has a devoted audience. I've got another video on the benefits of using xUnit later in the course. NUnit is the oldest .NET unit testing framework. This open source project has seen many changes over the years and has a robust third-party toolset. Finally, we have the Visual Studio unit testing framework. It ships with Visual Studio and is a good default choice. It is often referred to by the shorter name MSTest because that's the name of the test runner executable. All 3 frameworks use attributes to mark test methods. All 3 frameworks have an assert class that helps verify conditions in unit tests using true-false propositions. All 3 frameworks work within Visual Studio. You can see and run tests from the Test Explorer. If you are interested in a detailed look at the differences between the frameworks, there is a comparison documentation at this xUnit site. For example, it has a table that explains the attributes used by each framework. As you can see in this screenshot, NUnit uses the test attribute to mark a test method, MSTest has the test method attribute, and xUnit has the fact attribute. Further down the page is a list of assert methods. Once again, you can compare the syntax for each operation. Check out their docs. There's a lot more available there. Obviously, you need to choose one of the frameworks for your project. All of the frameworks are useful and simplify writing unit tests. Any one of them is a good choice for your project. I encourage you to spend a few minutes exploring these 3 choices and decide which one resonates with you. CodeLens has nice integration with unit tests. We will look at it later, but for now, I'm going to disable it in Visual Studio. To do that, I'll go to Tools Options. Then I'll search for CodeLens. Choose this top item, All Languages, CodeLens, and then uncheck this top check mark, and then click on OK. We'll enable it again later in the course. It's time to create some unit tests. The first step is to add a unit test project to our solution. You can see I've already added one here. I'll show you how to get your own. Let's have a word about the project name. I called it brokeragelive.xunit.tests. In the real world, I wouldn't have xUnit in the project name. I prefer calling it brokeragelive.tests. The reason for the longer name is to make it distinguishable from the MSTest project we'll add later. Let's see how to add that project. I would right-click on the solution and choose Add New Project. Then I would go to this drop-down and I would pick the type of project I want, a test project. I'll switch back to all languages for a second so you can see what we've got here. You can see there's a lot of different types of unit test projects. There's one for NUnit, there's one for MSTest, and the one that we're looking for is xUnit. So this is the one that we'd write xUnit test code in C#. If I search for xUnit here, I can see there's also one for Visual Basic and one for F#. So to reiterate, there are multiple languages we can use to write our tests. Since my code is in C#, I will pick this top one, xUnit test project, and click Next. Then I'd give it the name here, brokeragelive.xunit.tests, then click on Next. And I don't know if you noticed it or not, but we are targeting .NET Core for this test project. So I need to choose which version of the framework. So I'm choosing the current version, .NET 5. Then I would click on Create. Now I've already done these steps, so for this example, I'll just close out of this dialog. Now what do we have over here in this project? Well, we have some packages added. So you can see there is one from Microsoft called Microsoft.NET.test.sdk. And then there's xUnit. If you look inside here, you'll see there's the assert class, and there's something called xUnit.core and xUnit.analyzers. And equally important is its matching test runner, which is shown here, xUnit.runner.visual studio. So Visual Studio and this runner will collaborate to actually run our unit tests. The other thing is it added a unit test class. So if I open this up, you'll see it's very simple. It has a using system and using xUnit at the top, and then it's got a single class called unit test 1, and then it's using the attribute that marks this as a test method in xUnit that's called fact. To summarize what we've seen, we've added a .NET Core class library to the solution. We used the xUnit project template that gave us a head start because it added the testing NuGet packages to the project, and it included this single class file. xUnit is a free open source unit testing framework for .NET. Its philosophical approach to testing appeals to many developers, including me. Here's my thoughts on why you should consider it for your unit test framework. One note before we start, the other testing frameworks are not idle. They modernize their code periodically, so some of the benefits listed here might also appear in the other frameworks at some time. xUnit works with Visual Studio and other IDE tools like RaySharper, CodeRush, TestDriven.net, and Xamarin. xUnit also fits into continuous integration tools like Azure DevOps, TeamCity, and CruiseControl.net. Microsoft makes the MSTest framework, but many of their software teams use xUnit. Here is a partial list of some of the Microsoft code bases that are tested with xUnit. xUnit test attributes are extensible, so you can implement your own testing functionality. It has an elegant system for testing expected exceptions. Setup and teardown are two attributes on methods commonly implemented in unit test frameworks. They are used to perform initialization of the class before the test is run and cleanup of resources after the test pass is complete. However, many programmers complain that using setup and teardown in this way causes code duplication. In xUnit, the setup is done in the class constructor and teardown with iDisposable. This matches the way we do those operations in our application code. It has a better approach to parameterized tests. This reduces the number of tests to create. Write one test and provide a list of parameters to test all the edge cases. xUnit runs the test multiple times, once for each data set. Each test gets a new instance of the test class. This is better for test isolation. Therefore, data within the class cannot be polluted by other tests. Yet it is also smart about static state in the test class. That state will be shared between all tests. There are advantages to running tests in parallel. It is not unusual for a project to have thousands or tens of thousands of unit tests. Running those tests intelligently in parallel on a multi-core computer is a performance boost. How does xUnit decide which tests can be run against each other in parallel? It uses a concept called test collections to make that decision. By default, each test class is a unique test collection. Tests within the same test class are not run in parallel against each other. This means that it defaults to running each individual test class in parallel with the other test classes, but provides test isolation within each class. Ultimately, it's your choice which framework to use. xUnit is lean and extensible. It's smart about code isolation and boosts performance with parallel test runs. It has multiple ways to use data in tests, and it is smart on how it tests exceptions and events. For me, the benefits are clear. It's my default choice. To write the test methods, we need to put some classes in this project, this brokeragelive.xunit.test. Before I add the first class, I've got some thoughts on how to organize the test files. And this is using a concept that I've seen for writing or organizing your test in folders. I've written up some details here in this text file. So we're going to work with folders and .NET namespaces. So the basic idea is we have this namespace. Now I've shortened it a little bit. So we have a namespace called brokeragelive.test. This is our main namespace. And then we're going to create additional namespaces for each class. So I have the account class. I have the account namespace. I have a commission calculator class. I have a commission calculator namespace. Now, I'm not writing any tests for commission constant, so I won't create a namespace for that. But I do have financial and payment date. So we'll have namespaces for each one of those. And then there's another technique we can use that leverages a feature in Visual Studio, is that we can add folders with the same names inside the project. And that way, when I add the class files to the folder, it will automatically add the namespace correctly to the file. So we're going to create one folder for each namespace, like this: account, get commission calculator, financial, and so on. And then for each method that we're going to test inside the class, we'll write a class in that folder. Now that sounds confusing. Well, let's talk about that. Let's review what we have in financial. There is 3 methods inside the financial class: get rate of return, get annualized rate of return, and calculate loan payment. So I would create a class called get rate of return, another one called get annualized rate of return, and calculate loan payment. If you take a look through all of the classes I have in this project, you'll find that there are 4 folders needed and 7 classes needed to test everything. In the real world, this would happen organically. You'd write the tests as you're developing the code base. But for us in this course, we'll add them all at once. So I'll add a folder called account. I'll put that here, right click, choose to add a new folder. Then do the same thing for commission calculator. That's enough to get us started. And then I will go over here to the account folder, and I'll right click and choose to add a class. This is going to be called debit. You notice that it does the right thing with the namespace: brokeragelive.xunit.test.account, and then the name of the class is debit. Let's try that again. We'll go back to my notes. So I also need credit. That's going to go in the same folder. Once again, you see it does the right thing with the namespaces. Then over in commission calculator, I will need a class called get commission for the sale. Okay, I've added a couple of examples. Now, if you want, you can finish making the rest of them, create the folders and classes, or you can join me in the next video and use the ones that I will create. I've added the rest of the folders and classes. You can see them here. And it's now time to write test code to verify the behavior of what's in this payment date class. So I have a method called calculate future payment date, which, this is the business case here, calculates a payment date 30 days in the future from the provided date. And if the payment date is on a weekend, then move the proposed date to the first work day after the proposed date, which would be Monday. So the first test I want to write is to see if it returns a date 30 days in the future when the proposed date falls on a weekday. So that code is going to go in this class. So we'll make some changes in here. I usually like to add a using statement like that. So that aliases the brokerage lib namespace to SUT system under test. I need to make my test class public so it can be called from the test runner. I also need to add a method, return date 30 days in future when proposed date falls on the weekday. Make this a public test method. It's going to return a void. That looks good. And then remember when we were talking about BDD naming conventions, I said that the class should have the word should on it. We can either put it on the beginning of this method or I like putting it on the end of my class name. So I'll go up here and modify this to look like this statement, calculate future payment date should. Now, I don't typically change the file name. I leave the file name without the word should on it, but I like to put it here. So again, we'll read this like a sentence. Calculate future payment date should return date 30 days in the future when proposed date falls on weekday. Now let's compile. Make sure everything built okay. I do need a reference to the brokerage lib. I don't believe I have that yet. So we'll go into the dependencies and choose to add a project reference. Add a reference to brokerage lib. Next, I'm going to mark this method as a test method by using the fact attribute. And this is not going to resolve. So let's resolve this by adding a using xUnit at the beginning. Once again, I will build the project. So we're getting a successful build. We're going to go through the arrange phase. And what we're doing in the arrange phase is we're going to instantiate this class. So this class lives in brokerage lib.payment system. We'll copy that. Oh, and I don't need brokerage lib. So I get rid of that. That'll correct that error. So this should say that's the namespace. Now I need the name of the class, payment date. I really didn't need to copy that from this file. I should have just copied the end part of it. So that is instantiating the payment date class. And then I need to set up a sample date to test with. Now I need to pick a date that will meet the criteria. I happen to know this date will. This is in US English date format. So this is July 6, 2011. So that is the arrange phase. And now I want to do the act, which is actually calling the method. Let's review this line. So I created this new variable, results, which should be 30 days later. I then call calculate future payment date and pass in the sample date. And then finally, I need to have an assert in here that asserts whether the conditions I'm looking for are true. I'm in this fact-based test method, so I'm going to use the xUnit assert class. So I'm looking for equal. The first part of this is I'll do Control-Shift spacebar to bring up the helper. It says the first argument is expected. So I like to use named parameters, some of my code, and I think it helps make it self-documenting. So I would type in expected, colon, comma, and then we're going to do actual, colon. And I also want to put in the assert phase, a comment here. You don't have to put these comments in, but this is a common pattern you see with unit test arrange, where you set up the test, act, where you actually run the code under test in the system under test, and then assert that you get back what you expected. It's kind of redundant to have the assert comment here because you're using the assert class. So that's why I say this is optional. And at this point, we have a workable test, I believe. Let's verify that it compiles. At this point, we're ready to bring up the Test Explorer and see if this test passes or fails. A quick note for all the test-driven development fans watching this. I know I didn't write a failing test first. I know. I have my reasons. First, I'm not following TDD principles yet. Second, it's demo code. I knew what I needed to write ahead of time. We will see how to make new unit tests fail first, I promise. So we're in Visual Studio, and the main window that we use for working with our unit tests is called Test Explorer. So let's bring that into view. Go to View, Test Explorer. And it's here where you see all your tests listed, where you run your tests, get your reports. You can filter and sort and do all sorts of interesting with this window. It's too big to fit on the screen right now. There's really no good place to put the window when working on a single screen at this resolution. But my solution is to put it here on these tabs next to Solution Explorer. So I'll drag the title bar down here. Now I can see my files in Solution Explorer and see the Test Explorer. In Test Explorer, I can see there are two tests. Now remember, I only wrote one test in the last video. So where's that other test coming from? That's coming from this unit test number 1 CS file that was added automatically when I created the new project. See, it still has this fact in there. So one thing I can do, let's switch back over here, is I can remove this attribute, save the file, and you notice that it gets removed. Another way I could do this is I could delete the file entirely. So let's go put the fact attribute back in here, and it should reappear. And then another way I can get rid of this is to go here and delete that unit test1.cs file. And again, it'll disappear from this list. Notice I'm not having to rebuild my project. This is a relatively new feature in Visual Studio, and this is enabled in Options here at the top, Test Discovery. Discover tests in real time from C# and Visual Basic.NET source files. What's happening is Visual Studio is constantly scanning my code, and it knows what the valid test attributes are, like fact or test method. So it knows the attributes that are used in test methods. So it scans through my code and finds them. And when it sees them, it adds and removes the items from my list of tests. This is also a useful part of the live unit test we'll see later. When I add a new test, if I got live unit test turned on, it will run through the code again to verify that the tests are passing or failing. Now, of course, if you don't want to see this, you can turn it off here, but I like it, so I'll leave it on. I have my test. I haven't run the test yet, and you can see that is signified by the gray text here and the blue symbol. And when I hover over the symbol, it says not run. So there's several clues that I haven't run this test yet. I will run the test. Let me bring this over so you can see the outcome. So right now it says outcome not run. There's only a single test in the group. And I'm ready, so I can run it several ways. One is I can click here, right click, and choose run. And I see that if I go look down here in the tests output, I can see some information about that test run here. starting test discovery, and a lot of other information about what happened. Then I can also see that we have a green check mark now. And over here in this summary window, I can see that one unit test passed. And I can drill down and get additional information about the test here. Once again, we're running out of screen real estate. I'll slide this over. So I can see information about what was run on line 13 and so on. And you can also, eventually you'll get your error message when you have a failed assert. You can see information here in this test detail summary. So we've seen how to run a single unit test. It would be better to have multiple unit tests in here. So one thing I can do is stub in some code. So we'll go here, paste in some code. Mark this with the fact attribute. Save my file, and I should see a new unit test appear here. And I'll do that again with another test method. Save the file. Now I can see 3 tests appearing there. And you can see that these 2 have the not run symbol, and they also have the gray text. So I know that I've run one unit test, but I haven't run the other 2. Let's try running this one. Does that surprise you? It came back as passing the test. There's no code in my test method, and that's considered a passing test. Now let's examine more details of what's in this test window. I see that here's the old test I had that ran. It's now got a new symbol on it that says it passed successfully, but it wasn't run in this test run. This is the test that passed most recently, and this third one hasn't run yet. So of course I can keep running them individually, or I can go up here to this top level and choose to run all the tests in that section. Or I can select a couple by shift clicking and running those. I promised a failed test. I'll warn you ahead of time, this is a bit hacky. I'm going to assert that I have a true condition, and then I'll pass in false. Two passed tests and one failed test. And then as I mentioned, there's extra data over here that we can look at, and we'll cover what's in this area later in the course. It's common to have multiple unit tests per each method we're testing. I've added a lot more tests to the xUnit project. Let's take a look. The best place to see all of the tests is in the Test Explorer. Remember, I docked it to the right side of the IDE. It shares a space with the Solution Explorer. I have 22 tests in my brokerage-lib.xunit.tests namespace. There are 7 for the account class, 9 for the commission calculator, 3 each for financial and payment date. Well, we'll start by looking at the account class. I'm testing 3 methods. I'm testing the credit and the debit methods to ensure that the balance of the account is updated correctly. Sometimes you might find it necessary to test a constructor method. You definitely should do this if there's any logic in the constructor. I've included an example. Now here's a tip. If you're looking at your tests and you find the actual test, you can double click on it to open the code in the code editor. I named this class constructor should. There's only one constructor for the account class. It is a parameterized constructor that takes 2 parameters. So that's what I'm calling here on line 21. Now, a test you should run when you're testing a constructor is verifying that it instantiates an instance of your type. So that's what I'm doing on line 24. I'm calling assert not null, passing in my reference to see if I got a valid reference back from the constructor. And then these are optional. Some people don't feel it's necessary to check the property values in your type that are set in a constructor. But if you do want to write a test for that, that's what I'm doing here. I'm calling assert.equal, and I'm testing that the actual amount in the customer name matches my expected amount. And I do the same thing for the balance. Next, we'll look at debit. Here's the test that verifies that it updates the balance correctly during a debit action. I've also got a test for throwing exceptions when a negative debit amount is passed in as a parameter. I'll talk more about how you test or how you assert for exceptions later in this chapter. And then there's a business rule in this type that we freeze the account if they have a negative balance and they go below a certain threshold. So let's check out that test. It's called freeze account when negative balance below threshold. Here I'm debiting the account. I'm going below the threshold by setting the debit amount here to freeze balance +1. Then I call the debit method, and then I assert true that the account is frozen. So this is a Boolean property on the type. I also need to have an assert that verifies we unfreeze the account. So that's over here in the credit should. So again, I'm checking for update balance correctly during credit action, that it throws an exception when a negative credit is handed in as a parameter, and that it unfreezes the account when the positive balance is reached. So this one, I've actually acted and asserted twice. So the first act is to debit the account. Then I verify that the account is frozen. Then I credit the amount. In this case, it's this value here. So that should bring it above 0. And then I assert that this Boolean value is now set to false. Continuing our tour, we've got the commission calculator. Let's take a look at this epic commission one. This uses a new kind of test, or a new kind of attribute called the theory. This allows us to do parameterized tests, and I will talk about this in more detail later in this chapter. On to financial. We've got tests for the annualized rate of return that calculate payment, and we also have one for rate of return. And then finally, we have the payment date. Before I look at the code in here, let's verify that I can run some of these tests and that they come back green. So I'll go up to the account one. I'll click here to run all 7 tests on the account class. They all come back green. I don't know if you've noticed it, but across the top of the Test Explorer, when you run your tests, there's a progress bar. Now I tested my commission calculator. So finally, let's go take a look at calculate future date. Remember, I wrote some of this code earlier in the course. I wrote code on this one, return date 30 days in the future. So we've already seen that code. Let's take a look at the next test, which is return Monday when proposed date falls on Sunday. So I arrange it by instantiating payment date, choosing this date, July 8th, 2011, which I know causes a 30 days in the future to be on a Sunday. Then I do the act by calling calculate future payment date. And then here's my assert. Now, previously my assert was add 30 days to the date and check that the result I got back is 30 days later. What I'm doing on this test is I'm not checking the number of days anymore. I'm checking what day of the week the result is. So I say, check the date, find out its day of the week, and if it should not be on Sunday, it should be set to Monday. And of course, very similar code here in when proposed date falls on Saturday. So let's verify all my tests are green. I'll go to the very top item, run all the tests. In summary, this is a basic set of tests, 7 methods in the system under test, more if you count the constructors. I have 22 tests, with more coming as the code base grows. These provide a good sample representation, which we'll use in the rest of the course. xUnit supports 2 different types of unit tests, fact and theory. We've already seen the fact attribute in action. It's the simplest way to create a test method. A fact is a test method that has no inputs. Consequently, it is run as a single test. Arrange once, act once, assert once. In contrast, a theory in xUnit specifies that a test method does have inputs. With a theory, the test method is run multiple times, once for each set of inputs. We do this so we can test our code with different combinations of inputs. To say this another way, we create one test method, we supply a set of inputs. Our test will appear multiple times in the Test Explorer. There will be one occurrence for each test input. This is beneficial. We avoid unnecessary code duplication. There is no need to write multiple test methods that differ only in the data used to test the code. This does mean that we need to add one or more parameters to our test method. It also means we must provide data values for input into the theory. There are 3 possible sources for input data for the theory. The easiest and least flexible approach is to use inline data. we add the data to attributes on the test method. The inline data attribute is great when your method parameters are constants and you don't have too many cases to test. Another approach is to use member data. Now xUnit will pull the data from a static property or method on your test type. As you can imagine, this is more flexible. Now you can write code to generate your test data. Another flexible approach is to use class data. Now we create a class that contains the data. This custom class must implement a specific interface, that is, an IEnumerable of object array. This gives us enough information to make some theories. First, we'll look at inline data. Here's a good example of where we need to test with multiple parameters. This get commission for sale method. We have some logic in the code that says if the gross sale is greater than or equal to the epic sales amount, or the units sold are greater than or equal to the epic unit amount, the sales rep earns the epic commission rate. So we want to test this with a value that's greater than epic sales amount. And we also want to test it with units sold that are greater than epic unit amount. The member data attribute can be used to fetch data for a theory from a static property or static method of a type. In this example, I'll be working with a static property. I could define a static method. One of the benefits of doing that is I can also parameterize the static method and then alter the behavior of the data source. But I'm not going to be demonstrating that. Let's take a look at where I would define this member data. It's defined within a type. In this case, it's defined in my get commission for the sale type. And it's going to be data for this method, return standard commission when amounts are below threshold. Currently, I've marked this as a theory, and I am providing 3 bits of data through inline data. This means that when I run the test, I should get back 3 results. That's what I'm expecting, and I have 3 green passing tests. And now what I'll do is I'll comment out these 3 lines, and I'll substitute another attribute called member data. Now I have to tell it where to get the data. What's the property or method name? So that's up here. So let's go take a look at how I've defined this code up here in this property. So on line 8, I have a public static. The name of my property is standard test data. So let me copy that and bring that down here. So I'm telling xUnit that the data for this test is going to come from this property. And then look at the benefit of this. I can write code to generate the input values, any code that I want. So right now I'm just using some constant values like this, but I could write code to pull the data from any source. And that makes it more flexible. In the future, I can add new business cases to the source of the data, and I won't have to go in and modify my code here. But in my case, I'm just using constant values. This property has to return an IEnumerable of type object array. So in my case, I instantiated a list to hold the information of type object array. And the reason why it's an object array is because we can have 1 or more properties here. We indicate those by adding items to the array. You notice that I've duplicated the data that was down here. I have 3 rows where I'm creating 3 new objects, filling them with the test data. And now at this point, I think I'm ready to test. So I'll save my work, go back over here, get the same 3 passing tests, but now the data is coming from this property. We'll look at another approach to working with a theory test method. We can provide data by using the class data attribute. So when I do that, I have to tell xUnit where to find the type. So I use type of, then I specify test data commission standard parameters. That means I've created a class that is responsible for getting the data for the unit tests. Before we look at the code there, let me talk about one other change that I've made. I'll direct your attention to line 11. This is the old signature of my test method. It had 2 parameters. The first one was an int named unit sold. The second one was a decimal named unit price. I have replaced those with a more model-driven approach. So now I have a single parameter. Look at line 15. I have a single parameter, and it's of type commission test model. Press F12 to look at the definition of this type. Here it is. It's a struct It has two properties, unit sold and unit price, and you notice how they match the same types as I had for the two parameters. So what I would do if I'm taking this approach is for all my test methods, I would have a model type instead of a list of parameters. We'll go back over here and let's see how I use this model parameter. I'm using it here on line 20, where I call get commission for the sale. Now I'm saying model.unit sold and model.unit price. I'm also using it here on line 23. Now let's go take a look at the definition of this class. That's over here. I've defined it here on line 9. It's a public class named commission standard parameters. xUnit requires that I implement an interface called IEnumerable of object array. So I'm doing that. And when I implement this interface, I have to have a method called getEnumerator, which I'm doing here. I actually have two of them, but the one that's doing all the work is here. And it's deferring the work of getting the data to this item. What is this? This underscore data items. What is that? Well, that is defined on line 10. It's a private read-only field of type list of object array. And then what I'm doing is I'm populating that with information, the values from my unit test. But what am I doing? On line 12, I'm creating a new object array, and I'm only placing a single item in that array. I'm instantiating commission test model, setting the two properties, and then adding that single item to the array. Then I do the same thing two more times with different test values. So at this point, my class is returning an IEnumerable of object array that contains 3 instances of commission test model. Let's see if it works. So I'll go over here to my unit tests. This is the one I want to run. Now, in some of the previous demos, we saw multiple rows here for return standard commission, one for each set of data. When I was using like the inline data, there was 3 rows here. That doesn't happen anymore when I'm working with class data. Instead, we'll see the 3 results in this test detail summary. I have a green pass test. And then in the test detail summary, I see that this test has multiple test result outcomes. And here are the 3 tests. All 3 of them passed. And then I can get some additional information about those tests here. Writing asserts for values that contain decimal places requires us to think about precision. We need to consider how many decimal places of accuracy do we want when comparing 2 numeric values. In .NET, this is important for the float, double, and decimal types. Here's the scenario. I am testing calculate payment with this method, return correct annual rate given normal parameters. I have parameters of annual interest rate, duration in months, loan amount, and expected monthly payment, and I'm assigning those here in this inline data. So given these values for a loan, I expect to have a monthly payment of $798.36. In my assert.equal, you can see that because this is asserting against a decimal type, the xUnit framework provides me this extra parameter, precision. Currently it's set to 2 decimal places. So let's remove this. Save by pressing Control S, and then I'll go over here and run the unit test. It fails, and the reason it fails is I expected 798.36, and the actual decimal calculation was this number. So I want to round it to the first 2 decimal places. That's why we have the precision parameter. We'll undo everything, resave, and rerun the test. Exceptions will happen in your code base, and we need to understand how to manage them in our unit tests. We try to handle exceptions in our code gracefully, but unhandled exceptions do happen. This is especially true in early iterations of code where we are still resolving how the code should work. We also raise exceptions deliberately in our code. We might do this because we tried to handle the system exceptions in our code, but cannot, so we are sending an exception back to the caller. Some developers use exceptions to indicate that the caller is doing something wrong or the API code is in an unrecoverable state. Think about what this means when a unit test encounters an exception while it is running the test. Should that be considered a failed test or not. The default reaction in most unit testing frameworks is to consider the test failed when an exception is thrown. In the case of the unhandled exception, this is a strong indicator that there might be something wrong with the test code or the application code. When you see the failed test, you will investigate and fix the problem. Now let's consider the opposite situation, where our application code is supposed to throw the exception. In this scenario, we should write a unit test to assert that the expected exception occurred. Where should we start for this example? I think a good place to start is in this class, the commission calculator class. Let's look at the code in get commission for the sale. On line 21, I'm checking for units sold is less than 0, which means it's a negative parameter. And if that is the case, then I throw a new argument out of range exception. I do the similar action here on line 26, where I check if the unit price is less than 0, and I throw a new argument out of range exception. The messages are different, but it's the same exception. Now, let's go take a look at our existing unit tests. I'm looking at this one here, where returns a standard commission when amounts are below threshold. Double click here. That takes me over to the test method. And this is using a theory, and I've got multiple inline data here. Currently, I have positive numbers for all of these. So let's change one. Let's go to line 10 and make this a -1. I'll save the files. Then I'll go over here and run all the unit tests in this class. And it fails. And the reason it fails, click on it. At the bottom, it says there was a argument out of range exception. And there's my custom message. So that proves that if we are not specifically testing for the exception, our test is going to fail. The answer, of course, is to assert that we expected this exception. So let me set this data back to a positive number, save my file. Then we'll go look at the test, which is here. Actually, I want to do this test. Throws an argument out of range exception when negative units sold. We start out by setting units sold equal to -1. We have a positive unit price. I'm going to do the act and assert on the same line because we'll never get to the act part if we try to call the method directly, because it'll throw the exception. So what we do in xUnit is we call assert.throws, and we specify the type of the exception that we expect. We're saying we assert that this is going to happen. And then I pass in this lambda here that says call that method. So the test framework is going to call this method. And if the expected exception is thrown, this assert is true. Now we can optionally capture the exception information by assigning the asserts.throw to a variable. I think a better way to do that is to use the xUnit record exception. So that's what I'm doing in this next method. Here I arrange an act, and what I'm doing here in the act phase is I'm just recording. I'm saying, see if any exceptions happen when we run this method with these parameters. And if so, record all the information about it and store it in this variable. We're not asserting anything. We're just saying record what happens. Then I can use my normal assertion section of my test method to assert that we got what we wanted. For one, I can say assert that this is not null. And then I can also assert that it is type argument out of range exception. So now we have the three parts: arrange, act, and assert. Whereas in this other way of doing it, we don't have that. We only have arrange, and act and assert are in one section. So let's verify that these exceptions are thrown. So I'll go over here and run the unit test. It looks good. Run the other one. Now we've seen how to use xUnit to assert that an exception is expected. Context is essential when writing and debugging code. The more information you can have at your fingertips while writing code, the easier it is to keep your mind focused on the work, not the coding environment. While this test explorer is useful, we have to glance at another window to see the test results or to run the unit test. I have to move my focus from here to the test explorer window. Now, one tip I haven't shown you yet is that you can right-click on a test method, and run the test. That ran a single test. I can also go to the test class and run all the tests. And you can see I have one failing test. Now, what the topic of this video is the CodeLens feature. We can improve our workflow by enabling the CodeLens feature. This is a tiny inline info pane that gives you critical information about who's referencing the methods in the class and the status of the code base in source control. It also shows unit test results and other unit test tools. I disabled it earlier in the course, but I find it too valuable to leave it disabled. So here's how you re-enable it. Go to Tools, Options, search for CodeLens, choose all languages, and then click on this checkbox to enable CodeLens. There's a lot of options. I've disabled most of them except for Show Test Status, Show C# and Visual Basic References, Show Tested By. This will tell you who's tested the code. And I don't want the timeline for Git, so I'll turn that one off. And I'll click on OK. And you'll see right here between lines 8 and 9, this tooltip up here. Or it's actually not a tooltip, it's the CodeLens. And there's a green check mark there, and it shows that there are 0 references, but there's no code that is calling this method. I can also see that I have a passing test. That's the green check mark, and if I hover over it, it will tell me that the test passed. I can click on this to get more information. This tells me more details about the test, how long it took to pass the test, and I can also run the test again from here. Scrolling down the list, I see that this method also has a successful test, and we can see that over here too. But there is a failing test, so I'll keep scrolling down, and here I can see the failing test. I'll click on this, and now I get information on why it failed. It failed on the assert.equal because it expected Monday, and the actual result was Sunday. I think you'll agree that this is useful having this information right here in your code window. I don't have to glance over at the Test Explorer. In fact, I can have this Solution Explorer open over here, be looking at my code. And as I'm scrolling through my code, I say, oh, this unit test has failed. What happened here? So now what I'm going to do is go over to the payment date class, click here, go to definition. And at the top, I can see that there are 4 references to the payment date class. And this is interesting. Look at this method. Above that is a CodeLens that tells me that 2 of the 3 tests that are run against this method are passing and 1 is failing. Click here again to get details. This is the same information we see over in the Test Explorer, but it's in context. It's in line. It's right as you're looking at the code. So I don't have to wander over to Test Explorer and look through my list to find the details. I can do it right here from my code window. Now, why is this failing? It's something here. So I'll click on this version. It is because we saw earlier it was returning the wrong date. So line 25 shows me that I should have been adding 2, not 1. So we'll change this, save my changes, run all my tests. And now it shows me 3 of 3 passing. As I said earlier, I find CodeLens too valuable to leave it disabled. We will use it for the rest of this course. In the Test Explorer, it groups all the tests by the criteria shown in this dropdown. By default, it groups by the project, then the namespace, and then the class. So you can see that I've got 1, 2, 3, 4 groups. I can change the way it's grouped by choosing another item. Let's say I choose to group by project and then class. Now when I open up this dropdown, I see the individual classes, and then below that, the tests. That's not what I want to look at in this video. I want to look at adding our own custom categories to group by. And in xUnit, you use a trait attribute to do this. So we'll go up here and choose to group by traits. And these are traits that I select. It's basically a name value pair. So I've got categories like exceptions, categories like fact test, category, there's a theory of class data, there's a category theory inline data, and so on. I get to pick any value I want. So if I want to have the word category here, here's how I wrote the attribute. It's trait, and then the name that you want to appear, and then the value. So this is the name that shows up here, and then the value shows up in square braces. So this is flexible. You can pick whatever values you want. So I decided, for example, here we're using a trait name equals sprint, value equal 12. And notice you can have more than one trait on a method. Now, I don't like the way I created this one by category and then theory class data. It makes more sense to me to just change this to theory and then remove it from the value. And then I would do the same for one of these. That and remove it here. Notice that the groups haven't changed yet because I have to save, and then I need to build my project. Once I build, you'll see it updates. Now down here at the bottom, I've got theory class data and theory inline data. So the point for this is you can add your own custom metadata to your test and then group your test by whatever criteria you find useful. We have seen that when you're in the Test Explorer, you can group by different criteria. Currently, I am grouped by traits. Another thing you can do in Solution Explorer is you can run this subgroup. So I can run just the tests that are in this sprint 12. When I run the test, I find that 3 are passing and 1 is failing. Now, another way I can group the data is to go up here and group by state. Now, it'll show me that I have 1 failed test, 3 passed tests, and 16 tests that haven't been run yet. And now I can drill down and find out what's wrong here. So I just ran my tests in Test Explorer, and I have a failing test. Let's say I spend a few minutes looking at the code in my system under test, and I can't figure out what the problem is. At this point, I would like to debug my code. I'd like to debug my unit testing code to see if there's a problem there, and I'd also like to debug the system under test. The question is, how do I attach a debugger? What I'd like to happen is I'd like to put a breakpoint in my code, like I've done here on this unit test, and then I'd like to designate this method and run it with the debugger attached. Now, there's several ways I can do that. I can right-click on my method and choose to debug my tests, or I can use the CodeLens. I can click here on the red symbol and choose to debug, or I can go over to my Test Explorer and right-click and debug. Let's do that. Visual Studio starts up the debugger, attaches it to our unit test project, and then stops at this breakpoint. At this point, everything you know about how debugging in Visual Studio applies. The way you step through your code, everything works exactly the same. So I will press F11 to step through my code. I'm stepping through the code in my unit test, and at this point on line 53, I will step into this calculate future payment date. And now I'm debugging my business logic. I'll step through here, get to this point, and what I expect to happen is this to be the date Saturday. If I hover over this temporary date variable and look at the details, I see that the day of the week is Sunday. So I have a problem with my math here. I should have added 2 and not 1. So that's where my problem is. We developers depend on debuggers to troubleshoot issues. It's nice to know that we can debug unit tests with familiar tools. In this video, we'll look at a technique for resetting all the tests to not pass or clearing out the Test Explorer. First thing we want to look at is that we're grouped by traits. This allows me to right-click on a trait and run just a subset. In this case, it'll run 4 tests. And I see that I have 3 passed tests, 1 failed test, and a number of tests that have not run yet. I can clear or reset these back to not run by going to Build Clean Solution. What happens in Test Explorer depends on what you have set in your test options. I'm using Discover Tests in real time from C# and Visual Basic.NET source files, which means Visual Studio is going through and finding the tests automatically. If I disable this feature, I end up with an empty Test Explorer. The test will not appear until I build my solution. Rerun those tests. Now, when I go up here and choose to clean the solution, the behavior in Test Explorer is different. This time it cleans out the list. So it depends on how you like to work. Personally, I prefer working with the auto discover on, so let me reset that. So now we've seen there's two ways of cleaning out or resetting your Test Explorer. But all of them use the concept of cleaning your solution or cleaning your project. Let's look at what's in this drop-down menu, these top items. These allow us to run subsets of tests. We can also see these over in the test menu. Some of those items are at the top here. So let's talk about what these mean. So first of all, let me run a couple of my traits. I'll run my sprint, number 12, and I'll run this theory inline data category. So at the top, I can see I have 20 tests, 10 of them passed, 1 has failed, 9 of them are not run. I work on my code for a while, and then I want to run some of those tests again. A quick way of doing that is to go up here and choose to run all the tests in the view. I can just rerun my failed test to see if they passed. I can choose to run all the past tests to verify that they still pass. I can also repeat the last test run. And the final one we want to look at is run the not run test. So currently I have 9 tests that haven't been run. Rather than hunting them down, or I could also switch over to group by state. I could run them this way. But if you don't want to switch to a different grouping in Test Explorer, you can run all your not run tests by choosing this item. To determine what percentage of your project's code is being tested by your unit tests, you can use the code coverage feature of Visual Studio. The more code that is tested in the application, the more thorough your test results can be. This code coverage feature is available in Visual Studio Enterprise Edition only. In this video, we'll look at the coverage of one method in the system under test. So I want to look at see how much coverage we have for this method in Commission Calculator. It's this get commission for sale. I have 9 unit tests for that. You can see those over here. And I want to see if all those unit tests are covering the code correctly. What I'll do is I'll start by testing this test method, return epic commission when amounts over epic threshold. So the way you test it, or the way you check for code coverage, I should say, is to go over here, find the item, right click on it, and choose to analyze code coverage. After a few seconds, Visual Studio will bring up the code coverage results window, and it shows this current test, and here's the results. Now it gives me some statistics here, but that's not what I'm interested in this video. Also, you can see a list of your past code coverage tests available in this dropdown. Next thing you want to do is click on this Show Code Coverage Coloring. And this will highlight each line of code in one of 3 colors. Blue if it was covered, red if it was not covered, and yellow if it was partially covered. So you can see that all the code in my test method was covered, which makes sense. I told it to run the code here. So there's no problems with the code in this method. If I scroll up a bit, you see that one of my other test methods, return standard commission, none of the code was covered in here. That is sensible because I didn't tell Visual Studio to check the code coverage there. So it's coming back as not covered. What's more interesting is when we go over and look at the code here in Get Commission for Sale. Now I have the same coloring over here, and this lets me start analyzing what parts of my code were covered and which weren't. So I can see that my if statement here, that it correctly tested this value. This was false, so it didn't run any of the code in line 23 in the if block. Same here. It tested for this value. That was false, so it didn't throw this exception. And then down here, I've got some if, else, and else clauses. You can see that all the code in the first if block was covered. But because this was true, it didn't run any of the rest of the code in the else if or else. Now, I will try the next level, which is return earner commission when amounts over earner threshold. I should analyze the code coverage. It will run the code test and then store the coverage results. And now I'll turn on the coloring. Once again, you see that none of my exceptions were thrown. Now let's look at what's happening on line 33 and 34. The code coverage tool marked those as yellow. That means it was only partially covered. We're working with this conditional logical OR operator, also known as the short-circuiting logical OR operator, and it computes the logical OR of its operands. It doesn't have to evaluate the right-hand side when the left-hand side is true. Therefore, we get partial coverage. So we know that this part of the if statement was tested, but the other part wasn't. Then, of course, it didn't return the commission rate epic. Instead, it went down here and tested all this code. Now we'll do it for the last item, which is return standard commission. And we see that it ran this else block. So partially covered this if statement, partially covered this else if, and then ran the code here. I can check for all of the tests now. Let's go up here and choose get commission for sale should. There's 9 unit tests here. And everything's blue. So that shows me that my unit tests are correctly covering all possible lines of code in get commission for sale. Code coverage is useful. Here it's verifying a single method coverage. You might want to check the entire set of unit tests. We'll look at that next. In this video, we'll look at how to test for code coverage in the entire test project. So what I'll do is right-click on this top node in Test Explorer and choose Analyze Code Coverage. Then I'll open up my code coverage window. This time I am interested in looking at some of the statistics that are shown here. I'll expand this node, and I see that 78% of the code in my unit test library is covered. So there's some test code that's not being executed. We'll look at that in a minute. And then over here in the system under test, I see that we're around 74%. I have 100% coverage in brokerage-lib.payment system, but something's not being covered in brokerage-lib. When I open this up, I get some statistics about each one of the classes there. And I see that I have 0% covered for these classes. These are my constant classes, and I don't want code coverage there because there's no code to test. The one thing I can do is I can go over here and I can add an attribute to these classes to tell the code coverage tool not to test. It's called exclude from code coverage. I'll just add that to all 4 of my classes. Save. And then we'll recheck for code coverage. This is better. Now we're at 83%. You notice that those classes don't appear in my list anymore. Now what's happening next? Let's see. I've got 100% coverage on commission calculator, 100% coverage on financial, but I am missing some code coverage in account. It looks like one of the issues is with freeze account and unfreeze account. There's no coverage there. So let's see what's going on. Yep, it's not being covered. So let's go look at my unit test. I can see already that something is suspicious here. I've got 2 pass tests, and we have this yellow symbol, which we haven't seen yet, which says skipping for code coverage demo. This allows us to take a look at some properties that are available on the fact attribute. There's a skip equal true that I can set, which is basically telling xUnit don't run this test at the moment. And then I specify a string here to show in Test Explorer. This would be the reason why we're skipping the test. So, okay, that makes sense why we don't have code coverage for that, because I am deliberately skipping that. What else is happening here? Everything looks good here. How about I check the credit should? That would be this class. And you can see that one of our developers has commented out the fact attribute. That would be me, of course, for this demo, but this is one reason why it's not covering it. Or the more likely reason is we didn't write the unit test to test some part of our system under test. What I'll do here is just Control-K, Control-U to uncomment that. Do the same thing up here. Recompile or resave, rebuild. And check my percentage. We're at 100%. So the takeaway from this is we've got several tools. We've already seen the tool that lets us analyze the code paths through a method Using the techniques I showed in this video, we're analyzing all of the code in the system in our unit test and determining what unit tests we need to write and what parts of our code are not being exercised across the entire project. I'm feeling very good about my code coverage percentage. I've been testing and making sure all my code paths are tested, and I'm getting close. Let's see what we have here. I've got 100% code coverage in my brokerage lab, the system under test, and I have 97 or approximately 97% in my xUnit test. So let's see why I don't have 100%. These two classes, payment date and financial, have 100% coverage, but my commission calculator and my account class are close at 95% and 97%, but we're not all the way there. Why is that? Here I can see I've only got a 50% coverage on this method. So let's see why this is not covering everything. This method is testing that it throws argument out of range exception when negative units sold. Well, look at the code coverage. I see everything in this method was covered except this last bit where we called get commission for sale. We see it's a partially covered call to that method. And this has to do with how exceptions are handled in .NET. So if there's an unhandled exception thrown in that method, it's going to bubble up the call stack and return back to this method. And I am asserting that it throws that exception, but still, we're not testing all of the code. So this is a side effect of the way exceptions work in .NET and the way xUnit asserts them. You cannot get 100% coverage. At least I don't know a way to get 100% coverage if you are asserting that code throws in exceptions. You can get close, but you can't get to 100%. One of my favorite features in the unit test tools in Visual Studio is live unit testing. In this video, we'll look at how to enable it and start live unit testing. But first, let's talk about what happens in Test Explorer. When I'm in Test Explorer and I've run clean solution, I have a set of tests that have not been run yet. When I right-click on one of these items and run the test, Visual Studio goes out, runs my unit tests, and then returns the results in the Test Explorer. These results are static. They will not change. I can go edit my code. I can refactor my code. I don't know whether my refactor has succeeded or failed, or if I've broken my unit test unless I right-click and choose Run again to retest. Live unit testing allows us to have the test run in the background while you're writing your code. To turn on live unit testing, you go to the Test menu and choose this item, Live Unit Testing Window. That'll bring up a window. Typically, when I see it, when I'm first starting, it's in the middle of Visual Studio. What I've done is I've dragged it over and docked it here so it's next to my Solution Explorer and my Test Explorer. The Live Unit Testing window looks a lot like the Test Explorer. It has stats at the top. It shows how many tests and how many tests have passed. It has the ability to group. And I can also set my options for live testing. Now, one of the deficits of using live unit testing is it is a performance drain on Visual Studio. So you might want to control how much your unit tests run in the background. Let's go and look at options under live unit testing general. For instance, if I'm working on a laptop, I can pause live unit testing when the battery reaches a certain threshold. I can choose whether to start live unit testing on solution load, or I can pause live unit testing during build and debug. These are several options. I can also control how long a test case runs in the background before Visual Studio decides to time out. Once you've got your settings set, you click on OK. You go over here and you click on this Start button to enable live unit testing. Keep your eye over here in the left side of my code window for this Calculate Future Payment Date. Now I'll click on Start. I see a clock appear. It means it's starting to run my unit tests on a background thread. After a few seconds, I see that I have 22 unit tests available. I see that all 22 of them have passed. And I see these green check marks over here that tell me statistics about my unit test. For example, if I look at this line of code here, it tells me that that line of code is covered by one unit test. I click on that and it'll give me details. Let's try that again. Let's go up here to this top line where I'm on my method name, and I see here that this is covered by 3 tests. And you notice it's very similar to the CodeLens. If I click here, I can also run all the unit tests that are on this method, or I can debug them all. You may not want it running all the time, so you can pause it by clicking here and then restart it, or you can stop it entirely. Now you notice that the green arrows disappear. They won't appear until I restart it. Also notice that all my tests are grayed out at the moment, meaning that it's not currently running those tests. Click here to start. In the next video, we'll look at what happens when you start making edits to your code. Live unit test is really useful when you're refactoring your code or making code changes because you can see the status of your changes while you're editing your code. So let's say that I want to add a new case statement to this switch statement in my calculate future payment date method. As I'm typing my code, let's type in case. You notice that the green check marks are updating. And now I'm going to put my break in. And there was a little clock that appeared. And then after it reran the unit test in the background, I get a new green check mark here that says that this line of code has been just tested and is covered by 1 unit test. And again, I can click here to find out which unit test was testing that code. Let's say I make a mistake in refactoring. I'll go here and edit this. You saw that little timer appear, and now I get a red X in the border that tells me that these lines of code are failing. So when I hover over this, I see that there are 3 tests. 2 of the tests are passing, and 1 of the tests is failing. Same down here. This is covered by 1 test, and it's failing. Now I realize I've made a mistake while I'm refactoring my code. Fix this. It'll rerun the test in the background, and I'm back to passing tests. I'll move over here. You don't have to run all your unit tests. Let me stop my live unit testing, and then I'll click on this edit playlist. So this shows all of the tests that are being run in the background. Let's say that I want to disable all of those and only run some of the unit tests. Maybe there's a lot of performance hit and I'm only working in a small section of my code base. I only want to run the live unit test for that section. So I put a check mark here, then click on run. I still get the green check marks because I'm testing this part of the code. Let's say I'm not testing that part though, and I want to test the commission calculator. I do see that I still get a green check mark over here, but it's not actively running the unit tests on this test method. Running unit tests manually is useful, but running them automatically while making code modifications is even better. We've seen the live unit test feature, a nice way to get instant test results while working, but that is only available in Visual Studio Enterprise. Here's another way to get continuous feedback while coding that works in all Visual Studio 2019 editions. You'll find it here in Test Explorer. It's this item, Run Tests After Build. So click here once and then open the menu again, and you'll verify there's a check mark next to this menu item. When this option is selected, Visual Studio will execute the test methods automatically upon every successful solution built. Currently, you can see that I have 22 unit tests that have not run yet. We go down here and clear out my build output and clear out my test output. Looks like that's already clear. Then I'll go up here and choose Build Solution. You see the status bar running across the top of Test Explorer. I see all 22 of my tests have passed. I'll come over here and look in my test output and see that it successfully ran all 22 tests. Now let's take a look at what happens when I go up and I clear this out and then I build the solution again. Nothing happened. Nothing ran over here in the Test Explorer. If I go look at my tests, it's blank. There were no code changes, therefore no need to build the project, which means there's no need to run the unit tests. Now, of course, when I do make some changes, let's say I make the change to this formula, save my changes, build the solution, and I can see nearly instantly. It takes a little bit longer because you have to go through the build process, and that depends how long your build takes. But once the build is complete, then you can see, in this case, I have a failing test. So I know I made a change that has broke the build. We can use the Test Explorer group by feature to separate the test into subgroups. We've seen a few of these examples. They're up here in this dropdown, and we've looked at the default, which is project, then namespace and class, grouping by those criteria. We've also looked at grouping by state and by traits. In this video, I want to repeat talking about state, and I also want to discuss grouping by duration. Let's go and group by, and then I want to talk about what happens when you choose the top item. You notice that there's 3 check marks on the bottom. It's grouping by project, then namespace and class, but you can then disable some of these subgroups. So I'll click here to turn off grouping by class, click here to turn off grouping by namespace. Then I can add back in whichever individual items I want to the list. Now I'm grouping by 4 items. They're not the groups that are created by Microsoft that are specified here at the top. What I want to do is start by showing you state. So let's uncheck project, class, and target framework. Now I've just got one group by state. When I return back to Test Explorer, it splits it into 2 groups, the past unit tests and the not run unit tests. And of course, I don't have any failing tests, but if I did, there'd be a group for those as well. And of course, one of the benefits of Test Explorer and grouping is that I can then just run the tests that are in that group. Here's another group by you might find useful. It's by duration. We'll turn off state. Now it's only grouping by duration. It shows me that 9 of my unit tests are in the fast test category, but I haven't run the other tests. They're not run yet. So let's right click here and choose to run those. And now I see that one of my tests is at medium speed, greater than 100 milliseconds, and one test is slow at greater than 1 second. Now, why this is useful, first of all, it tells you when you have parts of your code that are slow or your unit test code is slow. It also allows us to run the subgroup. So I may want to run fast and medium most of the time and then wait and run my slow unit test when I take a break. If it takes a long time and I want to come back and look at the results later. So now I can come up here, run my fast unit tests. They're all passing. Run my medium unit tests. They're all passing. And I'll run these slow unit tests later. Grouping test is helpful, but we still see all the tests. For example, I have 22 tests and have grouped them by state. All 22 are still visible. Imagine you have a project with 4,000 tests. You might want to limit the tests you are seeing here in Test Explorer. We can use filters to find just the test methods we want to view and run. One way to do that is with the search box here at the top of Test Explorer. I'll type a string here, and when I press enter, the test list is filtered to display only those tests whose fully qualified names contain the string. So I will search for the word exception. I see that I now have 4 tests, not 22. And if I hover over these in the tooltip, I'll see every one of them has the word exception in the test name. Let's try another search term. I'll look for the word day. In this example, there are 3 results. And let's take a look at this first one. The day word is in the middle. It says should return date 30 days in the future. For this last one, it's on the end of the test name when proposed date falls on Sunday. You might notice that it is still grouped by my criteria. It's grouped by state. If I want to go back to the default, I can keep this filter, but change the way they're grouped like this. Now we're using the default grouping. We can also do other search criteria. I'll clear out this search and then go to this drop down. And over here, I can add what's called a search filter. So I can still search for a word, but I can also add other criteria like the state. For example, I can say I want to see only the failed tests. Clear that out. I can filter by all these other criteria like error message and class and fully qualified name and namespace. What I want to show is traits. So I'll go here and I'll look for the trait sprint. Let's go double click here. It shows me that here in this column where it says traits, that each one of these tests, there's 3 of them, have this trait sprint 17. So I'll double click here to take me to the test, and I can see that yes, on line 27, I'm using the trait attribute. The name of the trait is sprint. The value is 17. To save any of these filters for later use, create a playlist. I'll show you how to do that in the next video. Once you have your filtered list of tests, you can save it so it can be replayed later. This saved list is called a playlist. So I've created this filtered list based on trait equals sprint, which currently means there are 3 tests that meet that criteria. And I have grouped them in a new way. Instead of grouping them by project name and class, I'm grouping them by class only, which simplifies what we see in the Test Explorer. Now I'll expand all of the tests. What I'll do now is press Ctrl A to select all the tests. Then I can right-click and add the playlist. I don't have any playlists yet, so I'll add a new playlist. And that'll bring up a window. Typically, it starts out here in the center of your screen, something looking like this. And I usually take it and dock it over here with the rest of my test windows. Let's do that. This is my playlist called playlist number 1. And then I can run all the tests in this playlist. I'd like to save this for later, so I click the Save Playlist As. We'll call this one Sprint 17. Now let me show you another way of creating a list. I will switch back to Test Explorer, remove this filter. Now I'm seeing all the tests. I'll expand all the nodes. And then what I'll do is I'll find a test, click on it, and then hold down the Control key and click on another test. So this way I'm clicking on 3 tests. Now at this point, I'll right-click and choose Add to Playlist. I can add them to the existing playlist, but in this case, I want to add them to a new playlist. You notice that it adds another tab. So here's my original playlist for Sprint 17. Here's my new playlist, playlist number 2. I'll save this and give it a new name. Call this one Friday Example. Let's say these are all the tests that we're running on Friday when we're working. And now, again, of course, I can run just those tests. And then I can load those tests. So let's close these windows. I'll right-click here and close. Close this playlist here. Then later, when I'm in Test Explorer, I can click on this drop-down, open a playlist file. I can click here and go out and find my playlist. Click Open. Do the same thing with my Friday example. Now I've got my 2 playlists ready to go next to my Test Explorer. In this chapter, we'll explore MSTest as our unit test framework. We'll see how to add test classes, test methods, and other MSTest specific attributes. Then we'll look at how it is integrated into Test Explorer. The first step is to add an MSTest project to our solution. The solution I'm working with is called Work with Unit Test, and I've already added the project. It's called brokerage-lib.mstest.test. Here's how I did it. Right-click on Solution, choose to add a new project. In this Add a New Project dialog, I searched for MSTest. Then I picked my language, C#, and I picked the .NET Framework version of this unit test project. Then I click on Next. I give it a name, and I chose the most recent version of .NET Framework 4.7.2. Click on the Create button if you haven't created it already. Since I've already done that, I will close this dialog. And then we'll explore some more information about this project. We'll start by looking at the properties. Here you can see the target framework I selected, 4.7.2. And I picked that version because in Brokerage Lib, it's targeting that same framework. In the test project, there is a single C# file, unit test 1. This is a sample class that shows you how to create a unit test. So the way you do this in MSTest is you mark your class with the test class attribute, and then within that class, you mark each test method with the test method attribute. Now let's go take a look in Test Explorer. And I can see that Test Explorer has found the test. That's because I have this option turned on, Test Discovery. So it's discovering tests in real time. Now this worked in xUnit. It also works in MSTest. So it found the test. Now I can run all the tests. They're passing. That's because there's no code in this test method. So that's considered a successful test. I'll change that by adding an assert, but before I do that, let's change the name of this class. So I'll change the name, I'll save the file, and you'll see that it'll change over here in the Test Explorer. I'll do the same thing with the test method. Change the name of this. Oops, let's fix that typo. You see, it's discovered it even though I haven't saved the file yet. Now I can run those tests. It should still pass. And then in MSTest, it has an assert class. There's some for testing equality. They're called R equal. So right now I'll just say is 4 equal to 5, which is not true. And so that should return a failed test. So as you can see, it's very similar to the way it works in xUnit. Now it's time to add some real tests. To save time, we're not going to write all the unit tests manually. Instead, I've taken most of the examples from the xUnit chapters and converted them to MSTest. You'll find them all in this project. The first step was to go to References and add a reference to the brokerage lib. Then I copied all of the files over from one of my xUnit projects. And I used the same folder structure, so I have the account folder, the commission calculator folder, the financial folder, and the payment date folder. All the class file names are the same. All the class names are the same. All the test methods are the same. The major difference is in the code. I swapped out to using the MSTest attributes, and I changed the way I made my assert method calls. Other than that, the code is identical. Let's take a look. I'll start by double-clicking on Calculate Future Payment Date. So one of the things I had to change is on line 2, I had to swap out the using statement. So I'm no longer using xUnit. Now I'm using Microsoft.visualstudio.testtools.unittesting. Look on line 7. You can see that my class name is the same. It's Calculate Future Payment Date _ should. My test method is named the same. Return date 30 days in future when proposed date falls on weekday. I did have to change and add a test class attribute to the class. And I changed from fact to the test method attribute. You can also see, instead of using the trait attribute like I did in xUnit, I'm using the test category attribute to specify the category that this test lives in. Let's go take a look at this constructor.cs file. Here's another attribute that I changed. Instead of using the skip, I'm calling ignore to not run this test. And then we'll go look here and calculate loan payment. In xUnit, it's a theory if it's a data-driven parameterized test. In MSTest, it's called the data test method, and you provide data in several ways, including this way with the data row attribute. We'll look at data-driven and parameterized tests in more detail soon in this chapter. Let's see what these tests look like in the Test Explorer. I'm looking at Test Explorer, and I can see that Visual Studio has discovered 20 tests. I don't have quite as many tests as some of my examples in xUnit, but there's 20 tests available here. 7 for account, 7 for commission calculator, 3 for financial, and 3 for payment date. And all the things we learned about with xUnit apply here. I can run just the payment date tests by right-clicking here, choosing Run. You can see I have 3 past tests. I can run all the tests by clicking here. Currently, I am grouping them by the default, which is project, namespace, and class. But I can group by state. I can group by traits. This shows the test category here. So it's called traits in xUnit and test category in MSTest. But it's the same idea here. I can see my freeze test chilling and my freeze test thawing. I can see all my sprints. These are the tests marked as sprint 16. Here's the tests that work with exceptions. And here's my data-driven tests. All the other features are here. I can create playlist files. I can see my status up here at the top with these icons. I have 20 tests. 3 have been passed. 17 haven't run. I can run all the tests here. I can choose to run a subset from this list. I can debug my tests by right-clicking on the method name and debugging the test and putting breakpoints in my code. The point I want to drive home here is that everything we learned about xUnit applies here. It's just the code changes slightly. Let's run all the tests before we move on to the next video. That looks good. They're all green. There's a way to check for expected exceptions in MSTest. Let's take a look. Currently, I am grouping by traits. So I've marked some of my methods as exceptions as their test category. So I can double click on one of these to take me over to the code. This is the method, throw argument out of range exception when a negative price. The way you set this up in MSTest is to use an attribute. The expected exception is type argument out of range exception. So what will happen is as this test goes through and we get to this line of code where we actually call the get commission for the sale, there'll be an exception thrown somewhere in that method. None of the rest of the code in this method will process because of the unhandled exception. But because we marked it with this attribute, this will be considered a passed test. And let's verify that. Right click here and choose to run. Now let's change out the exception type. Let's choose argument null exception. This is the expected exception. This time I'll run it by right-clicking on the method name. I get a failed exception because it's not the correct exception type. Go over here and let's go back to this one and I will undo my changes before we move on to the next demonstration. Let's take a look at how you would do a data-driven test with parameterized tests. It's similar to the way you do it in xUnit. So I'm looking at this annualized rate of return should, in this method, return correct annual rate given normal parameters. So in xUnit, I would use the theory and inline data. It's similar in MSTest. I use the data test method. And this represents a suite of tests that execute the same code but have different input parameters. And then I use the data row to specify one set of those parameters. So this will get called one time with this information in the data row, and I'm passing in the parameters. So I add parameters to my method. There is one caveat with working with MSTest, at least for .NET Framework projects. I don't think it's quite the same in .NET Core, but the problem is if you're using an attribute, you can only use primitive types, and a decimal type and a date time type are not primitive types. So even though I really wanted to use decimals when I called get annualized rate of return, I couldn't do that when I set up this data row. So I had to change my parameters to doubles. And then inside the method, when I call get annualized rate of return, then I cast them back to decimal. Another thing I had to do is I had to figure out how to do precision. There's two ways I could have solved this problem. So when I called R equal, I have the expected rate, which is a double, and the calculated rate, which is a decimal. And I need to, first of all, cast this to a double. And then what I'm doing is I want 6 decimal places of accuracy. So I called math.round to get that to work. Another way I could have done it, there's a property on R equal. I think it's called delta I could have used. But I decided to take the math.round approach. Okay, so there we go. Let's see if it runs. I'll run my data-driven tests. Now let's run this twice with a different set of data. So I'll copy data row. And then I would need to provide the correct parameters and the correct answer, the expected results. I'm going to change this first parameter to 300 and then save the file, then run my tests again. And you can see that it failed on one of the runs because this value is not correct. When I'm doing my test down here for the actual and expected, it's not matching. But you do see it run it multiple times. Let me show you the other way you can do data-driven tests. It's over here in get rate of return. What I'm doing here is defining dynamic data. So now I can write a method that returns the data that I want. That's what I'm doing here. I specify dynamic data, the name of the method. This also works with properties, but you have to specify this enum value if you want to use the property. So I'm using method. Then I have a method written down here called get rate of return test parameters, and it returns an IEnumerable of object array. So it's very similar to the way it works in xUnit. Then I'm yielding out the 4 values that I want. These will be passed into the 4 parameters here. And then if I wanted to do more than one test pass, then I would just repeat this a second time with a different set of input parameters. Let's run this one. And it's running correctly. So that shows you how to do data-driven parameterized tests with MSTest. We've covered a lot of topics in this course. I'd like to share some additional resources. I find books invaluable for in-depth coverage of a topic. Going through the writing and editing process brings depth that you will not find in a 500-word web article. If books appeal to you and you'd like to study the philosophy of unit testing, I suggest these books. For a practical look at unit testing, consider reading Roy Osherov's The Art of Unit Testing, 3rd edition. It covers .NET, JavaScript, and Node testing in depth. Plus, it looks at concepts like mocks, fakes, and stubs. As I mentioned in the course, he talks about test naming too. It has a section on testing for async and observable code, another section on testing modular distributed services, and some tips on refactoring. Unit Testing Principles, Patterns, and Practices by Vladimir Korokov is another gem. It is deep and it presents thoughtful approaches to testing enterprise applications. It follows the domain-driven design principles, a system that looks to ease the creation of complex applications. I like the section on how to analyze the quality of a unit test, what it takes to write tests that have a good return on investment, and what tests are meaningless in the bigger scope. It is not only about unit testing, but also about integration testing. It describes differences, similarities, trade-offs, and benefits of these two types of tests. This is a pragmatic book on how to deliver maintainable software. If you enjoyed this course, may I suggest my other .NET and Visual Studio courses? Yes, I like Visual Studio. We've published more than 55 hours of content in my courses on this powerful developer IDE. Or if you prefer, check out my Azure Big Picture course, a broad overview of what is in the Azure ecosystem. Then I've got Git and GitHub content, including a look at the GitHub Codespaces feature. Finally, if you are a Windows desktop developer, check out my XAML and WPF content. I've got over 50 active courses in our catalog. I think you'll like some of them. Thank you for joining me for this course. Enjoy your journey of discovery into unit testing. Until next time, I'm Walt Ritscher.